Good evening, everyone. Good evening, friends. Welcome back to our session on NLP, Natural Language Processing. So, we'll quickly recap what we have covered in the previous session, then we'll start the topics for the day. So, in the previous session, we have understood, what exactly is NLP. We got introduced to this particular topic, NLP. Then, followed by, we understood what are the components that we have under NLP. Okay, so NLP is a subset, or I should say, it is a subfield of AI, right? So it is a subfield of artificial intelligence where we explicitly go and work on text data. Okay, so it focuses on the machines to understand, interpret, and generate human-like language. Okay, so in which at the end it should be some meaningful and useful, right? So focusing on understanding, generating, and as well as translating and analyzing. So all these things will be done by NLP concepts. Okay. So under NLP we have especially two components. Okay. So we discussed the history, and the key components under NLP are NLU and NLG. What makes the difference between NLU and NLG, friends? NLU helps us to understand the prompt that we give. Okay, so it focuses on understanding the language, the input that is given by the end user, and NLG component of NLP helps us to generate, produce human-like text. And we also discuss the differences between you know text mining and NLP. So text mining is nothing but text analytics. So the analytics that we do on the text, obviously, like we have related to the term data analytics. So in data, we have structured, unstructured, and semi-structured, and this text will be part of unstructured data. Okay, so if you are going to do any kind of analytics on the text data, it is nothing but text mining. Okay, so we are going to extract important patterns, features from the text data. Okay, whereas NLP focuses on understanding as well as generating human like language using these two components. Excuse me. Right? So, friends, if you haven't gone through the previous session, yes, do watch our previous session because we have started the foundations, like how we have understood the pre-processing steps on structured data. Even on unstructured data, we have pre-processing steps. So if you are explicitly going you're working on text data, then the same steps has to be implemented. So we understood lowercasing. So lowercasing, what does lowercasing means? Lowercasing is nothing but conversion of all the text into lowercase. So that means all the text whatever we have will be converted to lowercase. Why? Because this will help us to ensure that even though the words are in different cases, okay, all of them gets converted as single case, that is lowercase, right? So it treats all of these as same words. If not, it understands three different words in three different ways. Yes, it's simple, converting all the text into lowercase. Then what else did we discuss? We also discussed spelling correction. Yes. So spelling correction helps us to identify and correct the misspelled words. So within the text, if we have any misspelled words, those misspelled words will be identified and they will be corrected. So this actually helps us to work on the error part, and that will be done. And we also discussed tokenization. What do you mean by tokenization, friends? This is one of the important pre-processing step that one has to do. Tokenization is nothing but splitting text into, it might be words or sentences or subwords, whatever it might be. Okay, so in short, you are going to split your data into smaller units, and those are called tokens. So depending upon the type of tokenization that we use, you'll get either words or sentences or some kind of subwords. Okay, so in some types of tokenization, you'll also get punctuation marks as separate tokens. Yes. Okay, so we have a simple text over here. And what is corpus? What do you mean by corpus? Corpus is generally a collection of large amount of text data. Collection of huge amount of text data is nothing but corpus. And this corpus have sentences. So assume that I'm working on a paragraph. Okay, so this paragraph is around 10 to 15 lines, or let me assume that it is 10 lines. Okay, so this is called as corpus. Each and every line, each and every sentence is called document. Okay, so technical words are important because we are going to use them as part of the next pre-processing steps. Okay, so corpus is nothing but collection of text data, and you know this corpus will have sentences, and they are called as documents. They are named as documents. Okay, right. Then we also discussed the different types of tokenization. Word tokenization, it splits the text into individual words. Okay, so each and every word will be split as a token. So by default, it is going to assume it takes or it splits based on spaces and punctuation mark. Okay, then we also have sentence tokenization, which splits the corpus, which splits the text based on sentences. Okay, so under word tokenization, you get words as tokens, and under sentence tokenization, you'll get sentences as tokens. But we also have some challenges in all these different types of tokenization. Okay, so each and every tokenization have some challenges, friends. Then we also discussed tweet tokenization, which is explicitly designed for Twitter data. If you are working on Twitter data, we can also go and use tweet tokenizer, and we discussed with an example. Here is an example of a tweet and how exactly tweet tokenizer is going to give us the output we have over here. Then next to tweet tokenizer, we also have MW tokenizer. So this MW tokenizer is helpful when you want to, get multiple words as a single token. We go and use MW tokenizer. MW stands for multiple word expression. Okay, so discussed. This actually, is generally used in the case of NER, named entity recognition, and probably we'll talk about this topic in the upcoming sessions. Then regex tokenizer, we also have a tokenizer uh, which will be used based on regex patterns. So friends, there is a concept called regex, and this is a standalone module, a library in Python, and it works completely on text data. So it, you're supposed to define your patterns. So based on the pattern, it understands and starts converting, splitting the text into tokens. Then we have white space tokenizer. Wherever there is white space, based on the space, it splits the text into tokens. And tree bank tokenizer was also being discussed. It will work on a predefined rules, okay, that was followed by pen tree bank tokenizer and word punk tokenizer, which works on punctuation marks. So probably if you are going through all of these, that means you are going to cover each and every tokenizer, okay, that is available in the pre-processing step. So till here we have understood as part of the previous session, and in today's session we'll start with POS tagging, right? So it is parts of speech tagging. So do you remember parts of speech? What do you mean by parts of speech? How many of you remember parts of speech, my friend? No one? Seriously? In our school days, we used to, in English, we have parts of speech, right? Noun, pronoun. Yes, good. Okay, no worries. So, friends, this is an important step as part of text pre-processing. Okay, the main reason is each and every word in a sentence, each and every word will have a parts of speech. So, parts of speech tagging is nothing but it's a process of assigning, that parts of speech to each and every word. So, why should we actually do this tagging? Is when you give parts of speech for each and every word, computers, machines understands well. Okay, so when a sentence changes, obviously the parts of speech will change. So whenever you're going to uh, tag with the parts of speech for each and every word within the given sentence, the computers, the machines will understand that meaning of the text in a right way. Okay, so that is why parts of speech tagging is also done. As yes, we have adjective, verb. So you see, all of these are different parts of speech, friends. Noun, pronoun, verb, adverb, adjective, preposition. Preposition, conjunction, and interjunction. So all of these are different parts of speech, and we use them to tag for each and every word so that our machines understands the meaning of each and every word in a right format. Okay, so nothing much to talk, but that is where you see the flow. Initially, the text we have will be converted into tokens using any of the tokenizer. Okay, once after tokenization is done, we'll also start tagging with parts of speech, right? Then we can go and start our statistical analysis. Anyways, we'll discuss. Next, stopword removal. So if you have any kind of stop words, we are supposed to remove them. But first of all, we should understand what are these stop words. What are these stop words? Stop words are nothing but they are some common words that we use as connector words. Okay, so these common words are actually, they are used frequently as part of the text to bring some meaningful information. Okay, and some of the stop words we have over here, but in general they don't have any kind of meaning. Okay, they not have any kind of meaning. A, and, the, But without these stop words, these words, can you frame a sentence? Impossible, right? So we use stop words, I mean these words, and these words, they do not have any kind of meaningful information. So that is the reason what we do is, we remove them from the text, nothing but from the corpus. Okay, so here are some of the stop words, and whenever you're going to start working on the pre-processing steps on a text data, so obviously we'll be using some libraries, okay, within the Python. So we have libraries like NLTK, then text blob. All of these are some of the libraries that are widely used with respect to text pre-processing, word cloud and all. So whenever you're going to remove stop words, we have stop word removal. Okay, and there is an default folder or a file which contains some amount of stop words, and this particular file can be customized. You can customize. So by default, if it contains around 200 words, and all of these are some stop words, okay, when you're working on the text using this particular file, I'll remove all the stop words that are present in the text. What if there is a stop word that is not removed? And why it is not removed? The main reason is it is not present in these 200 words. Only if it is present in these 200 words, obviously that will be removed from the corpus. But if it is not present in these 200 words, okay, so that particular word will not be removed. So what you can do is you can customize this file. You can customize. Okay, when you can customize, obviously that word will be removed. So this will ensure dimensionality reduction, and moreover the performance will get improved. The main reason is, these connector words, these common words will be used more frequently, friends. Okay, so why? Because without these common words, without these connector words, we cannot frame sentences. That means we cannot have corpus. So that is the reason what we do is, are we interested in identifying these top words? No, we are not interested in these, right? So we are interested in the main words which have some meaning. For that, I'm just removing the stop words that I have. See, if I remove the stop words, I'll focus on the important words. For that reason, I'm removing. And here is an example. What is the example? The original text is like this. The quick brown fox jumps over the lazy dog. Okay, so what are the stop words that you observe here? The, then, over, and the. So within one particular sentence, I observe three stop words. Okay, and for sure you'll have the stop words, the connector words within the sentence, and you're supposed to remove them. Only then you can focus on the main important words, right? So we do it as part of the pre-processing. I hope it's clear. Then from here onwards, whatever we are going to discuss, so majority of these pre-processing steps will be widely used. Okay, so focus. Stemming. What is exactly stemming, friends? Stemming is nothing but the process of reducing words to the base or root word. Understood? No. So I'll take an example. Stemming is nothing but, if you have a word, okay, I'll take running as a word. And if I want to perform stemming on this word, what happens is it reduces that particular word to the base form. It is called as stem. Running is, it's a continuous action. Okay, so what is a base form? It is nothing but run. So the process of reducing the word to a base form is nothing but stemming. How this is done? Simple. By removing the suffix or prefix, you'll get the stem word, the root word. So if you see here, if I remove this ning, obviously I'll get my root word. Yes, the base word. In the same way, ner, I'll get my root word. If I remove s, so in all these three words, if I remove suffixes, so suffixes are nothing but whatever you add next to the text will be a suffix, and prefix is the characters that you add in front of the text, right? So in all these three words, if I remove the suffixes, what am I going to get? I'm going to get my stem word. I'm going to get my stem word. But the main challenge or main disadvantage of using stemming is, you know, the words returns that will be written as stem word may or may not have a meaning. May or may not have a meaning. Probably in this case it worked, but if you see here, consult, consultant. So I have many words using consult. What is the base word? Root word is consult. For consult, I am just adding the suffixes to get the rest of the words. But this is my base word. Am I right? So in majority of the cases, it fails. But in some cases, it works. I'll take a small example. If I take running and if I apply stemming on it, I'm getting the right stem word. Yes, I'm getting the right root word. But if you take happily, are you getting the right stem word? If you remove, the suffix from happily, you should get happy. But what is your root word here? It is again happily, which does not have any meaning in English language. So stemming is having a disadvantage. I hope it's making sense. So why should we do all these steps? We'll understand, we'll talk when we come across the use case. Okay. So if you remember 30 days free short-term training from Python to AI, what methodology did we discuss? Friends, which methodology did we discuss as part of this playlist? An important methodology has been discussed. What is it? I want everyone to answer. Don't sit idle. Crisp MLQ. Hope you remember. Right. So under Crisp MLQ, what did we do? It's a project management methodology which helps us to build AI or ML applications. Good. Okay. So using this Crisp MLQ, which has 6 phases, what is the second phase? Second phase is nothing but, yes, we do data preparation. So we are going to prepare our data as part of phase 2, in which we have 3 subphases: EDA, data cleaning, and feature engineering. So what is this data cleaning? In data cleaning, again, we understood 9 steps: handling duplicates, typecasting. So when you are learning them, you did not understand probably what is the use of these 9 steps. But when we start discussing the use cases, then you are able to correlate all these 9 steps in these use cases. Yes. In the same way, whatever we are discussing are data cleaning steps for text data. And these 9 steps are for structured data. Is it making sense or not? Don't get confused. Don't say, Akhil, already we have learned these 9 steps. Let us go and use all of them on the text data. No, impossible. Will you go and apply handling duplicates on text data? How can you identify duplicates? Not possible, right? I hope it's making sense. Whatever we are discussing now are some of the important text pre-processing steps, and we will be implementing when we go and do a use case, right? Yes. So stemming is nothing but reducing words to the base root, base or root form. Okay. So, but the challenge with the stemming is the root word or the base word that is written by the stemming, that is written as output by the stemming process, may or may not have a proper meaning in English, right? To overcome stemming, we have something called as lemmatization. So if you are good at these topics, it will be like a revision session. But if you're not probably aware of these topics, focus, right? So stemming has a disadvantage, and it is, I can explain it clearly over here. For running, it's working fine because the base root is run. If I add suffix, I'm getting all the 3 words. But if you take happily and if I use stemming on this happily, I should get happy as the output. But what is this happily? And moreover, it is this particular word is not present in English dictionary. There is no such word, right? So this is the disadvantage of stemming, and this will be overcome by lemmatization. And the general challenges that you observe in stemming is overstemming, understemming. Okay, so again, we have different types of stemming, like how we have different types of tokenization, tokenizers. We have different types of stemming as well. So all of them has the disadvantage. Okay, we'll discuss one by one. Let us not go depth to these particular stemming types because we'll understand how lemmatization is going to work. The first type is called Potter stemming because this was, developed by a scientist, and he is Martin Potter. So this particular type of stemming is renamed, it was named based on this person name. And the same purpose, what is the purpose of Potter stemmer? The same, to reduce any given word to the base or root form. How does Potter stemmer work? This is the question. Here are the steps. It works on 5 steps. So under step 1, you have two suffixes, then step 2, step 3, step 4, and step 5. All of them says remove suffixes and remove prefixes. That's it. So if you see in the step 1, you have remove plurals like ed, whatever the word ends with ed, ing, suffixes, go and remove them. Okay, then 1b says handle special cases like IED, EED. Okay, if you have any word ending with these kind of suffix, go and handle these special cases like agreed, agree. So in this case, it's working fine. Then in the same way, if you have any suffix with this or that, it works. But at the end, the same issue is being observed. Is there any word with this particular name? Happy, Happy. This is the English. There is a English word happy. So, you know, this is accepted. But what does Happy means? There is no word with this particular name. Right? So the same issue we observe in Potter stemmer as well. So we'll also discuss the other types of stemming, The second one is snowball stemmer. Okay, if you see, even snowball stemmer also works in a similar manner. Okay, but it's an improved. I should say it is an improvised version of potter stemmer. If you compare to potter stemmer, snowball stemmer is an enhanced version. Okay, so even the purpose of snowball stemmer is same. It is going to reduce the words to the base root, I mean base form or root form, and it is also the main, enhanced version that I'm talking about of snowball stemmer is it works for multi-language like English, French, German, Spanish, and more. Okay, so that is the major difference between snowball stemmer and you know potter stemmer, right? Then, but anyhow, the issue was not solved, friends. Even if you go and use the same word, you know, the issue is not satisfied. I mean, it's not rectified. Oh, happy is HAPPY. So it is misplayed. It is not giving the output in a right way, right? So this is not done in a right way. And for that, again, we have one more type of stemmer. It is the regex. Okay, this stands for regular expressions. So like how we have a regex tokenizer, we also have a regex stemmer, and this particular stemmer works uses regular expressions. Okay, so upfront you have to define your patterns. When you define your pattern according to your regex pattern, this stemmer is going to work. See, here we have some of the patterns. If I want to remove ing, my pattern should be like this: R within R, I mean next to R within the quotations ing dollar. So if the word ends with this particular ing, remove that ing is what it means. Okay, so regex is a library which is explicitly designed for text data, and moreover it completely works on patterns. Okay, so that patterns you have to learn. Probably if you don't remember, that's fine, because there are n number of symbols and there is a meaning for each and every symbol. Okay, so in our Python sessions, okay, in future we are going to do a session on regular expressions as well. We'll discuss how we are going to use the patterns and all, right? But anyhow, the challenge that we are facing in stemming process was not overcome, friends. Within the types, it was not overcome. Then came lemmatization. Okay, then we have lemmatization introduced. Lemmatization is also similar to stemming. So that means stemming and lemmatization both are same. Nothing but reducing that word to the base or root format. But what makes the difference is lemmatization, when it reduces the words, it will go and check. It uses a dictionary to evaluate whether there is a word, for this particular output or not. Okay, so that makes a difference. But in stemming, whatever the output that you get is may or may not have a proper meaning, whereas lemmatization, yes, you will have a meaning in the English language. Here we have, compared properly, where I took different words. The root word of all these words is improve. Obviously, by looking at these, we can tell improve, improving, improvements, improved, improver. Right? Obviously, the root word is improve. If I use stemming, I'll not get improve. I'll get something like improve. Okay. So, do we have any kind of English word with this? No. But when I use lemmatization, it cross checks with a dictionary, and the right word will be written as the base form. Okay, so that makes the difference between lemmatization and stemming. Both are used for the same process. But whatever the disadvantage, the challenge that we have while using stemming can be overcome using lemmatization. And this base word, okay, and this root word in lemmatization is called lemma. Lemma. Okay, so we have the comparison. Lemmatization is nothing but producing valid words, nothing but lemmas, root words, based on dictionary lookup and context. So it takes a dictionary for a reference, and based on the dictionary words, it is going to return as the lemmas, the root words. Whereas stemming, no. Right? So I'll not say that in all the cases we may not get the valid word, but in some cases, yes. That's why it is saying as which may not be a valid word. But if you ask the differences, you should be in a position to explain the difference between lemmatization and stemming. Right? So this is widely used, lemmatization. The reason is stemming has a disadvantage, a challenge. Then now let us quickly understand the different types of lemmatization that we have. We have rule-based lemmatization, dictionary-based lemmatization, machine learning-based lemmatization also. So, obviously uses different rules to form the lemmas. Okay, if you see better, if I take better as a word, okay, accordingly, if I use rule-based lemmatization, I'll get the root format as, or the base form as good. Excuse me. Okay, then dictionary based lemmatization, it is going to look up for a dictionary, okay, wherever the better word which is having as a parts of speech as adjective, it finds the word and returns good as the output. The base format is again good. Even the machine learning based lemmatization also will return good, but different. Here we have upfront rules defined, and under dictionary based lemmatization, it uses some kind of reference dictionary to find the words, the root words. And in machine learning based lemmatization, it uses some trained models to predict the lemmas. Okay, there are some trained models, pre-trained models. Using them, it uses, it gives the lemmas, right? So these are the main differences, but obviously you'll have the same word, but the way of getting the output will change. That's it, friends. Okay, and here are a few more types of lemmatization. I'll not probably talk about them, but you should have a clear understanding regarding stemming and lemmatization. Okay, so stemming and lemmatization, the process of, with respect to the context, both work in a similar manner, but there is a slight difference. Lemmatization will return as the right dictionary word, whereas stemming, it may or may not return a meaningful word. Just remember this process, that's it. Now we have a one more step, which is called word sense disambiguation. Okay, so what is this word sense disambiguation? Something it is talking about words, yes. So it's again a process of identifying correct meaning of a word in a given context. What do you mean by this? We'll understand. See, so like how we are going to get the root form using stemming and lemmatization. Each and every word will have a meaning, right? So there are some connector words, okay, some common words which don't have meaning and they are removed as part of stopword removal step. But there are some important words on which we are supposed to focus. These words, they have a meaning. And will this meaning be same across each and every sentence? Friends, can you tell me, if I take a word, okay, so will that meaning of the word will be same across different statements, sentences? The best example that I give is bank. No. Why? You see here, the word bank, if you take bank as a word, what does bank refer to? In general, if you say bank, obviously everyone will understand it is a financial institution where we, go and save our money. Okay, where we open our account and save our money. If not, we go and take some loans. So it's bank is referring to some kind of financial institution. But what does the same bank refer to with respect to river? Even side of a river is also called as bank. Excuse me. Even the side of a river is also called as bank. Yes. So there is a lot of difference for the same word depending on the sentence. I went to the bank to deposit money. So this is representing the financial institute. I am sitting on the banks of river. So that is referring to, the side of a river. So there is difference, and this can be identified. The right meaning, the correct meaning can be identified by word sense disambiguation. Making sense? So we also identify the right meaning using word sense disambiguation. Question bank, yes. So in the same way, there are n number of meanings for a single word. For a single word, you'll have n number of meanings, friends. So that can be identified. The proper meaning can be identified using word sense disambiguation. Okay, by understanding the statement. So according to the given sentence, it gives the meaning for the word that you are actually looking out for. Right. Excuse me. Now let us talk about the vectorization concept. So far, we have discussed all the cleaning steps. So at a glance, we will understand all the cleaning steps that we have discussed from start. We discussed lowercasing, converting the entire text into lowercase, followed by spelling correction. If there are any misspelled words within the text, we can also correct the spellings of the misspelled words. Then we started discussing tokenization, tokens. Okay. Then what else we discuss? We discussed parts of speech tagging, POS tagging. We discussed stopword removal. Okay. So stop words will be removed from the text. Then we also discussed the stemming, lemmatization. Then what else? And finally, word sense disambiguation. So all these are some of the important steps as part of text preprocessing. And from here to here, you are continuously working on text, right? Yes. So converting to lowercase is one step to the next step. Obviously, till here you are working on the text as is. But now this particular text should be converted into numeric format. Akhil, why should I convert it into numerical format? Why can't I keep the text as it is? So friends, whenever you're going to build a model, obviously you should have the data in the format of numbers, right? So for that reason, you are going to convert the text into vectors. You're going to convert the text, whatever the text that you have done so far, the pre-processing steps, that particular text has to be converted into vectors, and the process is called vectorization. Okay, why? This is for the next step where we are going to build a machine learning or a deep learning model. So that particular model will learn if the data is in numerical format. So for that, the first step that we are going to learn is bag of words. What is this bag of words? This is one of the important and the basic foundational concept of vectorization. How a text data is being converted to vector, nothing but numerical format. Okay, right? We'll understand. So whatever is present here, don't go through that. All the stuff not required. I'll just explain how this bag of words work and what exactly is bag of words. Bag of words is nothing but representing text data as a numerical vector. Simple. If you have text data, this text data will be converted as a numerical vector by using bag of words. How it is done, we'll understand step by step. What is corpus? Corpus is nothing but collection of documents. Is this the right definition of corpus? Yes. So friends, if you are going to work on an NLP project, or if you have completed working on an NLP project, be clear on the basics, because interviewers start asking you questions from your basic part. So obviously they can start from here, right? So corpus, what exactly is corpus? Corpus is nothing but a collection of text documents. What is a document? Document refers to a sentence. Okay, so corpus, for our understanding, it's a paragraph. I'm just giving an understanding word. So this paragraph, I'm technically naming it as corpus. Okay, so within a corpus, you'll have documents, and these documents are nothing but sentences. What we are going to do on the documents is we'll tokenize. Okay, so we'll make this document split into smaller tokens, either words, if not subwords, depending on the tokenizer that we use. Once after doing till here, we should use the concept of bag of words. Bag of words will come into the picture. So what you're going to do? You're going to count word frequency. What you're going to do? You're going to count word frequency. Identify or count the uh, you know frequency of each and every unique word present in that document. In each and every document, you'll have some words. Yes. So, what is the count of each and every word should be identified, right? So, here we have the step by step. Once after getting these frequencies, represent them as a vector. Done. Actually, seems like one hot encoding, label encoding. I remember, you know, one hot encoding and label encoding as part of pre-processing steps for structured data. Isn't it? Yes. Yes, friends. If you remember one hot encoding and label encoding that we learned as part of 30 days free short-term training from Python to AI, you know, you'll be clear on this particular topic as well. Because similar task. Here you're working on structured data, and bag of words is a topic that we implement on unstructured data. It is text. So what exactly this does is you are representing this text data in a vector form. So probably, can you give some examples, Akil? Yeah, sure. Just give me a minute. Here is the best example. You see the best example here. What am I doing? So my corpus. What is corpus? Corpus is a collection of, you know, documents. So how many documents you have? One. So this is two, and this is three documents. How many documents? Document is nothing but a sentence. So in a corpus, there are three documents. So after identifying the documents, what is the next step that I'm doing? I'm performing word tokenization. Okay. So I'll get the dog is happy for document 1. Yes, good. So I'm taking document 1, I'll get the tokens as the dog is happy. What does second document tell? The second document, on the second document, if I go and apply word tokenization, I'll get the child makes the dog happy. All of them are individual tokens. For that reason, we have them in square brackets. Within the square braces, we have the tokens. Now let us talk about document 3. I'll use the same, the third document, and let us tokenize it. The dog makes the child happy. So are we done with tokenization? Yes, we are done. We are done. What is the next step? Tokenization is done. Now go and count the word frequencies in each and every document. So in document 1, the is the word and the count is 1. Dog is the word and the count is 1. Is the word and the count is 1. Happy is the word and the count is 1. I hope it's making sense because it is not a complicated topic, right? It's a very simple topic. Converting text to vector representation is called bag of words. Excuse me. So in the same way, can I do it for document 2? Yes. The dog. What is the count of the? 1 here and 1 here. So that is the reason I see 2. Then child 1 makes 1. Dog 1. Happy, the count is 1. So you are going to simply encode the text. Whatever the text that you have, you're going to encode. So you see in the table, if you are representing within a table format, this is how your data looks like. Child. Within document, do you find any child? Is there any word child? No. So the frequency is represented as 0. Within document 2, yes, the count is 1. So let us keep 1. Same. Within document 3, the count is 1. Like this, I'll make a table. I'll make a table for each and every word. Child, dog, happy, is, makes, the. Okay. And in the final column, I'll come up with bag of word vector representation. So I'm representing the text in vector form. How? Simple. Whatever the values you have from here, from the column 1, start having all of them in a vector form. 0, 1, 1, 1, 0, 1. So this is how you represent a text to vector. Simple, friends. Okay, for better understanding, we also have an example, one more example here. So these are the documents, and I'm representing the documents in a table, okay, in which we have the words, the tokens, and the count, the frequency in each and every document. When you represent all of them in a vector, 1, 1, 1, 0, 0, 0. Yes, a priori. Good. So this is how we convert the text into a vector representation. Making sense? Yes. So if you have all the values, when I take all these values, see, I'm representing the bag of words, vectors here. These are all the vectors, vector 1, vector 2, vector 3. Okay. So when I represent all of them, what does this represent? Each and every row represents number of documents. Yes. And the size represents the vocabulary, the words, and the columns represent each and every word frequency, right? So this is how you are able to interpret as well. And I hope it's making sense. And we'll talk about n-grams. We have n-grams and TF-IDF vectorizer. Two important concepts are left out. So these two, and how we can visualize the text data using word clouds, sentiment and analysis, positive word cloud, negative word cloud, everything we are going to discuss in the next coming class. So until then, let us practice on any of the text data. Take the text data and start applying these, pre-processing steps. Okay. So friends, it's time for our questions. And before you ask your questions, if you feel that this particular session is amazing, just hit on the like button, support us, and also share across multiple the connections that you have. So whatever we are learning, implement them on the text data. Anyhow, I'll be doing it in the next class. I'll take a use case and I'll do it. Let us implement all of these excuse me, pre-processing steps on one of the use case, and let us discuss. Thank you so much, my friend. Do share across your friends, your connections. Ask them to join these sessions. Ask them to learn. Okay, sure, sure. Okay, so feedback link will be posted. Right. Thank you so much, friends, for joining and making the session interactive. I would like to appreciate our friends for joining on time and interacting with me continuously, so that I'm able to share my good amount of knowledge with you as well. So implement the same on daily basis so that we can grab good amount of knowledge. Right. So that's all for the day. Thank you so much for joining once again. We'll meet in the next session. Until then, take care. Have a great day. Signing off. Bye.